Now we're going to look at simplifying radical expressions using the product rule. So we can take the nth root of a times b and break it apart into two separate factors, the nth root of a times the nth root of b. The steps we'll go through are 1. Express the radicand as a product in which one factor is the largest perfect nth power possible, and then 2. Take the nth root of each factor, and 3. Simplification is complete when no radicand has a factor that is a perfect nth power. Some examples of this would be the square root of 18. We can break this into two factors, 9 and 2. We know that 9 and 2 multiply to get 18, and we also know that 9 is a perfect square, so the outcome from the square root of 9 would be 3, and 2 is not. 2 is an even prime number, and so it just stays as root 2. So we have 3 times root 2 as the simplified answer. Now let's practice these. In this first example, we have the square root of 50 x squared y to the 5th. Now it's going to be extremely helpful if you can think of these numbers inside the radicals as numbers multiplied together. And usually you need to think of them as a perfect square times some other number, because they're probably not going to give you example or practice questions where there's no perfect squares or perfect cubes. So you need to think about what is being asked. Well, 50 is 2 times 25, and 25 is a perfect square. So we can take a 5 out, and we'll be left with 2 inside. All right, so this is the idea we're going for, but before I get too carried away, let's just rewrite all the different factors inside the radical. 2 times 25 times x squared times y to the 6th. Now you have to think about how many times the index will go into the exponent. It's kind of like division. So let's rewrite this one more time. We have 2 times 5 squared times x squared times y to the 6th. We know the index is 2, even though it's not written there. And we ask ourselves, how many times will 2 go into 1? Well, it won't, so that 2 has to stay inside. How many times will 2 go into 2? Well, that will be 1 times, so a 5 will come out. Now, how many times will 2 go into 2 on the x squared? 1 time, so 1x will come out. How many times will 2 go into 6? 2 will go into 6 3 times, and so y to the 3rd will come out. The only remainder that didn't come out of the radical was the 2. So we have 5xy cubed root 2. Let's try that again with the next one. We have the cube root of a to the 6th, b to the 7th, c to the 13th. The same idea holds. We take the cube root, and then we ask ourselves, if we have 6 divided by 3, the index, how many a's will come out? 6 divided by 3 is 2, so a to the 2nd will come out of the radical. B to the 7th, divide it by 3. This does not have an even outcome, so let's break it up. Let's redo this, so it's b times b to the 6th. You would agree that that still comes out to b to the 7th, but now when we divide by 3, we have 2 b's coming out and 1 staying in. Now let's look at the next one. We have c to the 13th. Now c to the 13th is not going to evenly divide by 3. So let's try that again. Let's take c and break it apart from c to the 12th. C to the 12th does divide evenly by 3. So we'll leave c in. We've left b in, now we're leaving c in. The c to the 12th will divide and we'll have 4 c's that come out. So c to the 4th. We're left with third root or cube root of bc. Let's try this again with example 3 or c. We have the cube root of 128, a to the 3rd, b to the 5th, c to the 9th. We have to look at the exponents and determine if they're evenly divisible by the index. And so far, I can see that 1 is not. b to the 5th won't divide evenly, so we'll have to break that one apart. I'm also curious about 128. I know it divides by 2, and that will give me 64. And 64 is 2 to the 6th. So we'll have 2 to the 6th, which is 64, times another 2. So together, 128 is equal to 2 to the 7th. So let's rewrite this. The third root or cube root of 2 to the 7th, a to the 3rd, b to the 5th, c to the 9th. Now let's break it up. 2 to the 7th, 7 will not divide evenly with 3, so let's do 2 times 2 to the 6th, a to the 3rd, b to the 2nd times b to the 3rd. Notice I broke that up because 4 would not divide by 3 evenly, but 3 would, and then I have to make up for that because total this has to be b to the 5th. And then c to the 9th will already divide evenly with 3. Alright, so we're going to now take the index and divide each one of these radicals by 3. So I'll have 2 to the 2nd come out, a to the 1st come out, b to the 3rd, b to the 3rd divided by 3 will give me 1b, and c is to the 9th power, so if we divide that by 3, we'll get c to the 3rd. So the parts we're left with were the ones that were not perfect cubes. So what's left inside? Well, just the 2 and the b squared.